Welcome to MRL. In this learning session, we'll be learning about a number line and different number lines. Now, what is a number line? A line which represents numbers is a number line. We have got different types of number lines, and the first what we are going to learn is natural numbers number line. A line which represents natural numbers is a natural numbers number line. Draw a horizontal line, mark a point A on it. The point A on the horizontal line represents the least number 1 of natural numbers, and the other points B, C, D, E, F, G and so on, marked at equal distances from point A, represent consecutive natural numbers. We can use a number line to understand and work on the fundamental operations on natural numbers, that is addition, subtraction, multiplication and division of natural numbers. Now, the second important number line is the whole numbers number line. A horizontal line which represents whole numbers is a whole numbers number line. Draw a horizontal line, mark a point A on it, and point A represents the least whole number, that is 0. Then the subsequent points B, C, D, E, F, G, H, I, J, K marked on the horizontal line represent, and they are marked at equal distances, represent the consecutive whole numbers. Whole numbers number line also can be used to understand the operations on whole numbers, that is addition, subtraction, multiplication and division of whole numbers. The next important number line is the integers number line. A horizontal line which represents integers is an integers number line. So we have a horizontal line here. The point A is marked here on the horizontal line represents 0, and towards the right we have the at equal distances marked as +1, +2, +3, which represent the positive integers, and to the left again marked at equal distances represent -1, -2, -3, -4, -5 as negative integers. On the number line, the points to the left of 0 are marked at equal distances, represent what we call them as the negative integers. Remember that. The value of integers increase from left to right of the number line. Integers number line can be used to understand operations on integers. The important operations on integers are ordering of integers, negative of a negative integer, absolute value of an integer, addition of integers, understanding the sign convention, subtraction of integers, again understanding the sign convention, multiplication of integers, again understanding the sign convention of multiplication of integers, and division of integers, again understanding the sign convention of division of integers. So let us learn these operations with the help of a number line and understand the different operations and their sign convention. Let us learn about the ordering of integers. When we draw a number line, that is integers number line, we start from 0. Towards the right we have the positive integers, to the left we have the negative integers, and if you look at the numbers on the right side, +1 is on the right side of 0, therefore +1 is greater than 0, +2 is on the right side of +1, therefore +2 is greater than +1. So therefore remember, integers on the right of an integer is greater, and now if you look at -1, it is to the left of 0, therefore it is smaller than 0. We have -2 smaller than -1, therefore the integers on the left of an integer is smaller. Always remember that 0 is greater than all the negative integers, and 0 is smaller than all the positive integers. Remember that. -1 is the greatest negative integer. So that is about the ordering of. Now let us learn the next property of integers, that is negative of a negative integer. Negative of a negative integer is the integer itself. Let us understand this. Negative of 5 is -5. Rather, -5 is the image of 5. Negative of -5 is minus of -5, that is 5. That is the image of -5 is +5. So therefore the image of 5 is -5. The image of -5 is +5. Therefore negative of negative integer is the integer itself. Now let us understand this with the help of a number line. Now +1 is positive integer, the image of this is -1, and the -1 is the negative integer, the image of this is +1. Therefore minus of -1 is +1, and minus of +1 is -1. So please remember that, and this is generalization here. a is a positive integer and minus of a is a negative integer, that is minus a, and negative of negative a is again a, that is the image of minus a is plus a. Therefore remember, the image of 1, image of that is minus of minus 1 is plus 1. So you take the image of plus 1, it is minus 1. We take the image of minus 1, again it becomes plus 1. Therefore minus of minus 1 is plus 1. Now the next important property to understand is the absolute value of an integer. The absolute value of an integer is the numerical value or the magnitude of the integer. For example, if you take plus 5, it is 5 units to the right. If you take minus 5, it is 5 units to the left. So the magnitude of plus 5 or minus 5 is 5 only. Therefore we say the absolute value of 5 by putting two parallel lines across 5 on either side of the number 5 is 5, minus 5 is also 5. Therefore whether it is plus 5, the value is 5, whether it is minus 5, again the value is 5. It is, therefore remember that absolute value can be 0. It can never be negative, because plus 5 is also 5, minus 5 is also 5. So that is the absolute value of an integer. Therefore remember, the absolute value of an integer is the numerical value or the magnitude of integer, and the sign has got nothing to do with it. Now let us study the operations on integers, that is addition, subtraction, multiplication and division of integers. Now let us consider the first important property, that is operation, that is addition. If you take the integer set, that is z is equal to 0 plus minus 1 plus minus 2 plus minus 3, if you pick any two integers from this, that I have taken here plus 5, add plus 3 to it, then plus 5 plus 3 becomes plus 8. Let us take the number line and understand it. Now 0, 1, 2, 3, we are indicating the positive integers on this number line. From 0, jump 5 units to the right, that becomes plus 5, and 3 has to be added, jump 3 steps to the left, to the right again. So 5 plus 3 becomes plus 8. Therefore plus 5 plus 3 is equal to plus 8. Let us take one more example. Minus 5 is a negative integer, minus 5. Minus 3 is also negative, we have to add them. So from 0, jump 5 steps to the left, that is minus 5, again 3 steps to the left, that is minus 8. Therefore minus 5 plus minus 3 is minus 8. Therefore now what is the conclusion here? If the integers are both positive or negative, that is they have like signs. Here you see both the integers are having a plus sign, therefore they have like sign. Here both the integers have minus sign, and that means like sign. When the signs of the integers are like signs, then just add the numbers, just add 5, 3, it becomes 8, and put the same sign. Here plus 5 plus 3, add the numbers 5 and 3 is 8, put the sign plus. Here add the numbers 5 and 3, it is 8, put the same sign minus, and that is the rule of addition of integers. Remember that. Here I have taken one more example. Plus 4 plus of minus 2, that is plus 2. Plus 4 plus of minus 6 is minus 2. Let us understand this. Now if you take the number line, plus 4 means 4 steps to the right, that means plus 4. Then minus 2 means 2 steps to the left, that is plus 2. Therefore the addition of plus 4 and minus 2 is plus 2. Similarly, if I take plus 4 to the right, plus 4 to the right, and minus 6 to the left, from 4 minus 6 to the left, that means 6 steps to the left gives me minus 2. Therefore plus 4 plus of minus 6 is minus 2. Now what is the conclusion here? Here if you observe, the signs of plus 4 and minus 2, they are unlike signs, and therefore the procedure is subtract the smaller number 2 from the bigger number 4. 4 when you subtract 2 from that, you get 2, and put the sign of the bigger number. Here the 6 is having minus sign, and 6 is greater than 4. Subtract 4 from 6, we get 2, put the sign of the bigger number. Therefore the rule is, if the integers are of unlike signs, then subtract the smaller number from the bigger number, and put the sign of the bigger. Now the next important operation on integers is subtraction of integers. Now 6 is an integer, 5 is an integer. We want to subtract 5 from 6. 6 minus 5 is plus 1. 6 minus 5 is plus 1. Now the procedure is, actually subtraction is nothing but the addition. It's an addition procedure. Only the difference is that we have to take the additive inverse of 5. Now if I have to subtract 5 from 6, that means I have to add minus 5 to 6, and 6 of plus of minus 5 becomes plus 1. As you know, the signs are unlike. Subtract the smaller from the bigger, put the sign of the bigger, therefore it is plus 1. And by using a number line we can explain this. Now we are jumping 6 steps to the right first, that is plus 6, and then minus 5, that is 5 steps to the left again, so the answer is plus 1. So that is how we explain using a number line. Therefore, remember, the rule is every subtraction is an addition by changing the sign of the subtrahend. That means if you want to subtract plus b from plus a, then change the minus to plus, change the sign of plus b. That means take the additive inverse of plus b, which is minus b, and therefore it is a plus of minus b. Now, to understand with an example, if you want to subtract plus 7 from minus 8, write minus 8 as it is, change the sign to plus, and write the additive inverse of plus 7, that is minus 7. So minus 8 minus 7, the signs are like here. Add the numbers, put the same sign. 8 plus 7 is 15, and that is minus 15. Now, one more example. If you want to subtract minus 10 from minus 8 as it is, you write it, change the sign minus to plus, because addition you have to do. Take the additive inverse of minus 10, that is plus 10. If you look at the signs are unlike. Subtract 8 from 10, that becomes 2, and put the sign of the bigger number, that is plus 2. So that is how we learn about the subtraction. Now coming to the next important property, that is multiplication of integers. If you want to multiply 3 into minus 5, that means I have to multiply minus 5 3 times. That means on a number line, from 0, 1 step to the left, that is minus 5, second step to the left, that is minus 10, third step to the left, that is minus 15. Every time I have taken 5 steps to the left, and therefore, and that I have taken 3 steps to the, that is 3 times I have taken minus 5 steps to the left, and therefore I have got minus 15. Rather, the conclusion is 3 into minus 5 is minus 15. This also can be explained in another way. Minus 3 into 5 is minus 15, because 2 into 5 is 10, 1 into 5 is 5, that is 5 less, 0 into 5 is again 5 less 0, minus 1 into 5 is again 5 less, that is the minus 5, again minus 2 into 5 is 5 less, that is minus 10, minus 3 into 5 is again 5 less, that is minus 15. So therefore remember, when the signs are unlike, 3 is with positive sign and 5 is with the negative sign. When the signs are unlike, subtract, that is multiply 3 into 5, that is 15, plus into minus is minus sign. Therefore, when the signs are unlike, it is always with a negative sign. Minus, whether 3 into minus 5 is minus 15, minus 3 into 5 is minus 15. So multiplying integers with unlike signs, multiply the numbers and put a minus sign. Remember that. The next important study is about rational numbers, number line. A horizontal line which represents rational numbers is a rational numbers number line. So we have a horizontal line here, and the rational numbers are represented on this line, and therefore it is a rational numbers number line. Towards the right of 0 are the positive rational numbers, to the left of 0 are the negative rational numbers. Every point on the number line marked at equal distances represent rational numbers. On the right of 0 are positive rational numbers, on the left of 0 are negative rational numbers. Now, how to represent rational numbers on a number line? If I have taken, let us consider an example here. Represent 3 by 5 and minus 3 by 5 on a number line. So let us draw a rational numbers number line and represent these numbers. I have drawn a rational numbers number line here. I have marked 0 as a point here. Towards the right I have marked 1, and towards the left I have marked minus 1. So mark point 0 and 1 and 0 and minus 1. Divide the distance between 0 and 1 and 0 and minus 1 into 5 equal parts, because the denominator is 5 here. Divide into 5 equal parts, and each part will be 1 by 5. That means 0, 1 by 5, then 2 by 5, then 3 by 5, and 4 by 5. Similarly, minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 5 by 5 is 1, and 0 by 5 is 0, 5 by 5 is 1. Now after having marked it, locate the numbers required to be represented. The 3 by 5, the point P represents 3 by 5, point Q on the number line represents minus 3 by 5. Therefore remember, the points P and Q on the number line represent the two rational numbers to be represented. The next important study is about irrational numbers number line. A horizontal line which represents irrational numbers is an irrational numbers number line. The decimal expansions of irrational numbers are non-terminating and non-recurring. To locate irrational numbers on a number line, we follow geometrical method, because it is difficult for us to measure the length of irrational numbers, because the decimal expansions are non-terminating and non-recurring. We can understand the method of locating the irrational numbers on a number line a bit later in our second session. So this is what we have learnt about number lines up to irrational numbers number line. Further, in our next part, we'll be proceeding with learning of the real numbers number line, and also the procedure of locating irrational numbers on a number line, and also locating what we call real numbers on a number line. So let us learn all those in the second part of our study. Okay, thank you.